Hello everybody, and welcome back to my series on creating a password manager from scratch. This is part 2, and if you haven't seen part 1, I'm going to put a card up at the top. You should go ahead and watch that before you watch this one. And today, I will show you how I've created a Python front end for my password manager. This is just a proof of concept, but as you can see, it says welcome to your password manager, and it's asking me if I want to log in. And so I will. I have already made an account, and you can do imadetests@email.com, and here we can see we're presented with multiple options. We can view our vault. In this case, we have 3 saved logins. We can see that we have YouTube, Stack Overflow, and Steam. And we can also add a login. We can provide a name. Let's just say Yahoo, and the website would be yahoo.com. We will provide no description, it's optional, and we can say Yahoo user at yahoo.com, and let's just make the password 1234. Don't do that in real life, but this is just for show, and we can see that it's added it to our vault. We can also do things like remove the login. Let's say we don't use Yahoo anymore, and we can just select login 3, and it will remove it from our vault. We can also update the master password. In this case, I'm using password 1234. This isn't very much more secure, but let me choose password 1. And you can see that it's changed. So now we can try to log in again. Test@email.com, and then use password 1, and we can see that login was successful. So before we jump right into the code, I think that I should show you guys the theory behind how this works. So the first thing that I'd like to go over is the concept of key generation. So basically what this does is it takes your email and your password, and it runs through a function called pbkdf2, or password-based key derivation function 2. It runs through 100,100 iterations, and that gets you your vault key. Then your password and your vault key are combined and ran through pbkdf2 another 100,100 iterations, and that gets you your auth key. Your vault key is used to decrypt and encrypt your vault, which I'll talk about in a moment, and your auth key is used to prove that you are who you say you are. This is at least how LastPass does it, although there's many different forms of this. Note that because your password and vault key are combined and run through the function again, LastPass, or any password manager, doesn't actually know your vault key. It only knows your auth key. This way, your vault key is actually never stored in the database, so an attacker that is able to leak the database would not actually have access to your vault. They would only have access to your authentication key. The next idea that I'd like to review is vault access. It's a simple idea. Basically, you take your vault plaintext, which is however you're actually storing your passwords so that you can read them, and it runs through some kind of encryption function. In the case of LastPass, they use something called AES, or Advanced Encryption Standard. There are many different versions, but basically it just takes your vault key, and it gives you your encrypted vault. AES is a type of symmetric encryption, meaning that the same key can be used to decrypt and encrypt. So then you can take your encrypted vault, use that same vault key, and get your vault plaintext back. I'll go into this in more detail when I actually show you the code, which we can jump into right now. So the first step for any new project is obviously creating the new Git repository, which is always a fun experience. And I think I'm just going to call this Python Password Manager and my Python frontend to my password manager. And I'm going to leave that public so that you guys can check out the code, add a readme file, and then I'm going to add a git ignore, set that to Python this time, and let's just go with the GPL 3.0, create the repository, and let me just clone this really quickly, and let's just go right in. And I have learned from my last video, and I'm just going to do one development time lapse and then explain everything afterwards. So I'm going to put a chapter in the YouTube description so you guys can skip that if you want to. And I'm just going to dive right in. I'm now done, and I've organized the code to make it easier to understand. And I guess first I'd like to go over just the general operation of the program, and then I'll go into each detailed section. So basically, first it just says welcome to your password manager, and then it keeps asking you if you would like to log in, or the alternative is to register for a new account. If the user wishes to log in, then we ask for their email and their password, and we use the Python built-in getPass function, which is really helpful. And then we generate a vault key and an auth key from the email and password, and then we try to authenticate. If we successfully authenticate, then we enter this, and this just is a while true that asks you what you would like to do. So the options are view vault, add login, update master password, remove login, and quit. All of this logic is pretty gross, but basically just what it does is if you picked an invalid choice, then it keeps asking you again, and each choice is input using an integer. 0 is view vault, 1 is add login, 2 is update master password, 3 is remove login, and 4 is just if you want to leave. This is just in case during development I broke something, and this is in case that you fail to authenticate, and this is if the request actually fails. Then if you want to register instead, then you provide your email, you provide a password, it generates a vault key and an auth key, and it makes a new vault for you. It encrypts the vault and then sends it to the register function. Here you can see all of our API access functions, and I made a class in here called result, and all it does is store if the request was a success or not, and it stores the text, which is just the body of the response. And I made this make request function that just takes the API URL defined up here, and it combines it with your endpoint and then sets the headers to headers and actually makes the request. And the success is just checked if the status code of the response is HTTP 200. Here's our authenticate function. It just takes your auth key and it puts it into the headers and it makes a request. All of these are exactly the same, just what goes into the headers changes and the endpoint changes. So here we get a little bit into the cryptography aspect, and LastPass actually does 100,100 iterations, and I decided to just double that for fun. I don't know if that makes you feel more secure or if it doesn't mean anything to you. And here we just generate a vault key, we take the email and the password, we encode them as UTF-8, and then we run the password-based key derivation function 2, and it uses SHA-256 as the backend, so we'll generate a 256-bit key afterwards, and then we do it for the proper amount of iterations. Here you can see that the way we combine the email and password is that the password is the main data, and the email bytes are actually the salt. Because emails are all going to be unique, we can use them as the salt, and that works perfectly fine. Here we generate the auth key, and it's basically the same process. We encode the password again, and then we just run everything twice with our vault key and then our password bytes. Here's actually all of the functions that were called in the main.py that basically just actually do these different requests and everything. So here we can say view vault, and all it does is it gets the vault, and then if it was actually able to get the vault, then it just lists all of the logins in a human-friendly manner. Add login action just takes the name, websites, description, username, password, and it creates a new login, and then it adds it to the vault. And then we actually update the vault, and then we're done with that. Here's the remove login action, so it basically just gets the vault. It lists out all of the logins in a sort of friendly manner that allows you to tell which one is which, and then you input the index of the one that you would like to remove, and if you pick an invalid index, then it just cancels. Here we can see the update master password action, and it just asks you for your new password. It tries to generate the vault and auth keys, and then it attempts to update the key. So this is one place where our front end really has to be very secure, and I'm considering updating the back end to make this easier. But if that update key works, then we actually need to update the vault. Because if you think about it, if we've updated our key but not the vault, then next time we go to decrypt our vault, it's going to not give us the correct answer. So we also need to update our vault, which is now encrypted with the new vault key. And the only issue comes with if that fails. So just in case, I put this in here that if that fails, then we try to update the key back to the original. And if that fails, then you're just out of luck. That actually hasn't happened at all, but theoretically something could go wrong with the network, and which is why I'm thinking that next time I might update the backend to make all of this one operation. Here are just some utility functions. You might have seen return or request vault. It just takes the vault, and if it is none, then it requests it, and if it's not, then it just returns it. So it's just a surefire way of either getting the vault or just passing it along. And return and update just updates the vault and then returns the updated vault. Here we can see create login, it just makes a new dictionary for us, and get confirm password just takes your password, asks you to confirm, and if they're not correct, and if they don't match, then it just continues to ask you. Here we can see the vault class. It's very simple. All it does is take a JSON string and then it turns it into a dictionary. Here we can see the new function, which just takes this default dictionary, and you can see that I put version 0.1.0 and then added lists for logins and notes, and that just turns itself into JSON and calls the constructor. Here we can see the decrypt from function that I made that takes an encrypted vault and your vault key and it attempts to decrypt it. So for this proof of concept, I chose AES, but I chose mode SIV, which stands for Synthetic Initialization Vector. And it's sort of, in this case, because I don't use a nonce, it makes the decryption and encryption deterministic. So if you take the same key and the same data and you run the encryption, then it'll produce the same result, which can be undesirable in some cases, but I figured it was fine enough for this. But I'm considering doing it differently in my actual implementation of this. But here we can see that we just take the vault and then the tag, which is used to verify that everything is correct. And we decrypt and we get our plain text back. What's more interesting slightly is how we do the encryption. We turn ourselves into JSON, we encode ourselves as UTF-8, and then we go into mode SIV with our vault key, and we encrypt and digest our vault bytes. And this does produce the ciphertext and the tag, which I mentioned earlier, which is just to verify that we actually got the data back that we actually wanted, which would be very useful. And then we just have our add login and logins functions, and we have our remove login function. So that's actually it for the code. It was really simple. It's only a few hundred lines. The link to the GitHub repository will be in the description. And like I said, next time I might be changing up the backend, but most importantly, this is going to be out of Python and into a web front end, which I'm really excited about. And if you look forward to seeing that, then subscribe and like the video and leave a comment down below and let me know how I did in this video. And I will see all of you guys in the next part.